Have you ever really thought about what happens when you hit the power button on your Linux machine? In that split second between a dead screen and your login prompt? It seems like magic, right? Well, it's not magic. It's a fascinating and super fast journey, and in this explainer, we're going to pull back the curtain and demystify the entire thing, step by step.
Yeah, it's something we do every day without even thinking about it. But that one simple press kicks off this incredible, perfectly timed dance of software and hardware. It takes your machine from just a quiet box of parts to a fully alive, ready-to-go operating system. So today, let's pop the hood and see exactly how that dance works. All right, here's our game plan. We're going to start with the very first spark of life, the firmware. Then we'll cross the bridge with the bootloader and the kernel. After that, we'll watch the whole system come alive. And finally, we'll tie it all together with an analogy and talk about why this is so cool to know.
Okay, let's get right to it, starting at the absolute beginning. Before Linux even has a clue what's going on, the computer's own hardware has to wake up and, figure out where it is. And that is the job of the firmware. So what is firmware? Think of it as the computer's most basic instinct. It's a little program that lives on a chip right on the motherboard. Its one and only purpose in life is to be the very first thing that runs when power hits, and its job is to kickstart everything else. Seriously, without this first step, nothing else happens. Now, you've probably heard of these two, BIOS and UEFI. BIOS is the old-school classic you'd find on older machines. UEFI is the new, modern standard. And yeah, they have some big technical differences, but for what we care about today, their role in the boot process, they basically do the exact same job, get the ball rolling.
So the firmware has two really critical jobs. First, it does what's called a post, or power-on self-test. It's just a quick check-in with all the hardware, like, hey RAM, you there? CPU, you good? Once it gets a thumbs up from everyone, it starts looking for a bootable device. When it finds one, its job is done, and it passes the baton to the next runner in this relay race, the bootloader.
All right, so the hardware check is done, everything's looking good. But how do we get from this super low-level hardware stuff to actually running a massive, complex thing like the Linux operating system? Well, we need a bridge.
And on pretty much every Linux system you'll ever touch, that bridge has a name, GRUB. It stands for Grand Unified Bootloader. GRUB has one main goal, to find the heart and soul of the operating system, the Linux kernel, and pull it right into the computer's memory. It is the essential link between the hardware waking up and the OS taking over. So what's GRUB actually do? Well, if you've ever dual booted with Windows or another OS, you've seen its menu. That's GRUB. But its most important task by far is to load two very specific files into memory. The Linux kernel itself, which is usually a file called vmulinux, and something called an initial RAM disk, or init ramfest. And let me tell you, that second file is the secret key to this whole operation.
And just like that, the star of the show has arrived. The Linux kernel is now officially loaded into memory. This thing is the brain of the operation, the absolute core of your entire system. From this moment on, it has total control over the CPU, the memory, every piece of hardware. It is in charge. But hold on, there's a really interesting little problem here. The kernel is running in memory, but it doesn't actually have the drivers it needs to talk to your hard drive yet. So it knows the operating system is somewhere on that drive, but it can't see it. It's like it's awake in a completely dark room. It's powerful, but it's blind. And this is where that initrams file saves the day. It's a tiny, temporary little world loaded into RAM, and it contains the one thing the kernel desperately needs: drivers, specifically the drivers for your hard drive. This file basically hands the kernel a flashlight so it can finally see the rest of the system.
Okay, this right here is the major turning point. With those drivers from initrams, the kernel can finally see the real world. We're about to make the jump from this little temporary bubble into the full-blown, real-deal operating system that we use every day.
So, using those new drivers like a key, the kernel unlocks and mounts the real root file system. That's the main slash directory on your drive. This is the big switcheroo. The temporary initrams world is completely thrown away, and now, finally, all of your real system files are accessible. Now that it can see everything, the kernel has one final, monumental job to do. It starts the very first program that runs outside of the kernel itself. This is the first user space process, and it's so important that it is always given the legendary process ID number 1. So who is this VIP, process number 1? On basically any modern Linux system, it's a program called systemd.
You can think of systemd as the great ancestor, the parent of every single other process that is about to run. Its entire job is to look at its instructions and then piece by piece bring the rest of your system to life. Systemd does this using something called targets. Think of a target as a goal. For a server, the goal might just be a command line interface, which is the multi-user.target. For your desktop, the goal is the full graphical experience, or graphical.target. And on the way to hitting that target, systemd starts up all the services you need, networking, your SSH server, databases, you name it. And finally, once systemd has successfully launched every service required for its target, it does the very last thing we've all been waiting for. It fires up the login manager. And there it is. Our journey from a dark screen to a ready-to-use system is complete. Okay, I know that was a whole bunch of technical jargon, but don't worry. To make sure all of this really sticks, let's map it onto a super simple, real-world analogy. So just imagine your computer isn't a computer at all. Instead, it's a big company office building that's just opening up for a new day of work. Every stage of the boot process we just talked about has a job to do inside this company. Let's break it down. The BIOS, or UEFI, that's the security guard at the front gate, doing a quick check to make sure the building is safe before unlocking the doors. Then you have GRUB, the bootloader. That's your friendly receptionist who points the first person to arrive to the right floor. That person is the kernel, the CEO, who immediately takes charge and decides the plan for the day. The CEO then tells systemd, the general manager, to get everyone working. Systemd goes and wakes up all the departments, which are the services, the employees doing the actual work. And the login screen, that's you, finally arriving at your own desk, ready to start your day. So, why did we go through all of this? Why does knowing these steps actually matter? Well, beyond just being cool, it's incredibly useful for two big things: troubleshooting when things go wrong, and, yeah, for absolutely nailing technical interviews. Understanding this process really makes you stand out. So here's your interview cheat sheet. If you're ever stuck trying to fix a machine that won't boot, or you're in an interview, knowing these facts is a game changer. Being able to casually mention that the kernel is usually at /boot/vmunews, or that grub's config is in /boot/grub2, shows you know your stuff. And the real pro tip? Explaining that systemd is always PID1, and knowing you can prove it with PS-P1, that's how you show you've really gone deep. And there you have it. We've taken the entire journey, from a simple flick of a switch all the way to a fully running system. We've peeked inside that so-called black box and seen the elegant, logical process that happens silently every single day. The mystery is gone. So the only question left is, now that you've seen how this works, what part of your system are you curious to explore next?